Hello all, I am Dr. Bharath Kumar, Assistant Professor, Department of Mathematics, Madanapalle Institute of Technology and Science, Andhra Pradesh. In this video, I am going to explain the Gauss-Jordan method for finding the inverse of a square matrix. This method uses the elementary row transformations for finding the inverse of a given matrix. Before going to explain this method, it is necessary to understand the elementary transformations of a matrix. There are mainly three elementary operations. The first one is for interchanging rows or interchanging columns. It is denoted by Rij for interchanging ith row and jth row. Similarly, Cij for interchanging ith column and jth column. Here, I and j indicate the positions of a row or a column. For example, if I take a 2 by 2 matrix 1, 2 and 3, 4 and applying the transformation R12, which means that first and second rows will be interchanged. The matrix will become 3, 4 and 1, 2. The same thing will be happened in the case of columns, where I am applying the operation C12. The second operation is the scalar multiplication of each element of a particular row or a column. It is denoted by k times Ri for the row and k times Ci for the column. Here k indicates the non-zero scalar and it can be a fraction. Let's see what will happen for the same matrix 1, 2, 3, 4 if I operate with 2R1. It will multiply the first row by 2. Similarly, the transformation 2C2 transforms the second column from 24 to 48. The third operation is the combination of previous two operations. Here, Ri plus Krj will replace the ith row by sum of itself and the scalar multiple of jth row. Similar transformation will be done in the case of columns, which is Ci plus Kcj. Let's elaborate with the previous example 1, 2 and 3, 4 and apply the transformation R2 plus 2R1, which means the second row will be replaced by the sum of itself and twice of R1. Thus, the new transformed matrix is 1, 2 and 5, 8. Similarly, while applying the transformation C1 minus 3C2, the first column will be replaced by the sum of itself and minus 3 times of C2. Coming back to our topic, Gauss-Jordan method, where we have to apply the elementary row transformation to transform the given matrix to the identity of same order for its inverse. First thing here is to understand the procedure to find the inverse using this method. There are mainly three steps involving here. Initially, write the given matrix A and I, which is the identity matrix of same order, side by side. Then apply the successive row transformations simultaneously to both the matrices A and I till the matrix A transformed to the identity. At the same instant, I is transformed to a new matrix B. The new matrix obtained in the second step will be the inverse of the given matrix A. Now let's apply this method by solving an example. Consider a non-singular matrix A is equal to 8, 4, 3, 2, 1, 1 and 1, 2, 1. As we already discussed, we need to place the given matrix and the identity matrix of same order side by side. Next, we need to start applying the elementary row transformations to convert matrix A into identity. First, check the first row and first column element is 1 or not. If not, we need to divide the entire row by the same element, or we can swap with another row whose first element is 1. Here, we have 1 in the third row, thus we can swap third and first rows by using the operation R13. After making the first row and first column as 1, we need to make the below elements of 1 as zeros. For that, the required row transformation is R2 minus first element of second row, which is 2 multiplied by row 1. Similarly, the third row, the transformation is R3 minus 8R1. These will transform the matrix to a new matrix where the first column is 1, 0, 0. Now make the second row, second column element is 1 by dividing R2 with the same element. Here we can simplify third row also to make the calculations easier. After making the second row, second column element 1, convert the above and below elements to zeros using the transformation R1 minus 2 times R2 and R3 minus 12 times R2. Repeat the same procedure for making the third row, third column element as 1 and the above elements of it as zeros by applying the transformations R1 minus 1 by 3 times of R3 and R2 minus 1 by 3 times of R3. This gives the transformed identity matrix of given A. Also, the right side matrix is the required inverse of A. Now let's verify the final answer by multiplying both A and its inverse. We'll get A into A inverse is equal to identity.
Therefore, the obtained matrix is the inverse of A. Thank you very much.